Hello everyone, I am Biswaksen Patnaik. I am a PhD student in computer science at the University of Maryland, College Park. Today, I will be presenting our work, Sensemaking Sans Power Interactive Data Visualization using color-changing ink. This work is done in collaboration with Dr. Huaishu Peng and Dr. Niklas Elmqvist. Our decisions in the present-day world are becoming increasingly data-oriented, wherein we use a plethora of devices to interact with information visualizations. These computational displays dynamically refresh with additional information as we interact with visualization, which helps in cognition. At the heart of these devices is electronic computation and power that helps us access information almost anywhere. Well, I do say almost, because what happens when we do not have access to electronic computation and power in scenarios such as the print media, books and newspapers, posters, or infographic maps of trails and animals in a national park? Can we make interactive data visualizations without electronic computation and power? Yes, we can. We use color-changing inks that change color depending on external stimulus for data visualization. Here's an example of visualization that changes between two distributions as one places their hand on it. This is a printed book. There is no electronic components or power involved. Now the question goes, how does this work? We use thermochromic ink in this example. This ink changes from color to colorless when heated. In this example, the heat from the human hand brings about this change. As the person places their hand on it, it heats up the ink, changing its appearance to colorless, revealing additional information. There are various types of color-changing inks that are commercially available today that change their appearance based on external stimuli. Thermochromic inks respond to temperature. Photochromic ink responds to UV or sunlight. Photoluminescent inks glows in the dark. Solvatochromic ink responds to a solvent. Piezochromic ink responds to a force, stretch, or an impact. Chemochromic inks respond to certain chemicals in a gas. Now let us look how we can leverage the characteristics of these inks to explore the design space of creating interactive visualizations. A mark is a basic graphical element in an image. We explore ways of altering the appearance of a mark with compositions of color-changing ink and regular ink. By appearance, we mean how do we make a mark appear or disappear with stimulation. Let's look at this scenario where a mark appears with stimulation. For this, let us use stimulus-activated ink. An example of such an ink would be a photochromic ink that changes its appearance from colorless to color upon stimulation with sunlight or UV. In this scenario, we simply paint the mark with stimulus-activated ink. Upon actuation, it reveals itself. In this scenario, a mark disappears with stimulation. We are still using the same stimulus-activated ink, such as a photochromic ink. In this composition, we use two layers. One, which is made of regular ink, and the second, which is made of the color-changing ink. Let us have the mark painted with a regular ink on the bottom layer, and we have the color-changing ink on the top layer. When it's not actuated, the color-changing ink's appearance is colorless, thus we see the mark. But upon actuation, the top layer becomes colored, thus making the mark disappear. We can have similar scenarios for stimulus deactivated ink, such as a thermochromic ink that changes from color to colorless upon stimulation. Now we have explained all the scenarios with different kinds of ink, stimulus activated as well as stimulus deactivated ink, in scenarios such as appearance of a mark with stimulation and disappearance of a mark with stimulation. We show how color-changing inks compositions are used to alter channels, such as position, color, length, and area. We use commonly used marks and channels in information visualizations. There are two tables shown in this illustration. Here on the left, we show an example with thermochromic inks that respond to heat and goes from color to colorless. We show how thermochromic ink is used to alter different channels, such as position, color, length, and area. We show how thermochromic ink has been used to alter the position of a point, line, area, color of a point, line, area. How do we change the length and area of a line and an area going from big to small or small to big. Similar analogy can be made with photochromic inks that goes from colorless to color upon simulation. So this forms the very fundamental idea behind interactive visualizations with color changing inks. We show how we use color changing inks to alter marks in channels, which will form the very basis of designing interactive visualizations without any computation and power. So we use the properties of color changing inks and systematically explore the design space to make interactive visualizations anywhere without electronic computation and power. Here is an example. This is a pie chart that shows crash data by day and night. The pie chart changes as sunlight hits. We show this with a UV light in this video. Additional information is revealed as sunlight hits the chart. Here is another use case. Here we show a data physicalization model. Here is a topographical model of the Zion National Park, which is overlaid with animals seen at different areas during day and night. We emulate sunlight and heat of the day by using a UV light and a heat gun to demonstrate how the example changes and shows different tints, and how the color changes, which shows what animals are visible at a specific time of the day versus night. There are a few limitations to using color changing inks to make interactive visualizations. Temporality and occlusion. Reversible changes make it hard to perceive as occlusion occurs with hand interaction. These color changing inks are reversible and they start reverting back to their original state once the stimulus is removed. And especially when you're interacting with a color changing ink composition with your hand, you need to place your hand on it to bring about this change, which will create some occlusion. Accuracy. Sometimes color changing inks could give a washed out look. Cost and compatibility. Color changing inks are expensive compared to regular printer inks, and these are not commercially compatible with the commercial printers that are available. Discoverability. We need additional information to understand how to use a color changing ink composition. Complexity. In this work, we show simple two-layer compositions, but this does open up prospects for future work where we can explore how multiple kinds of color changing inks be combined, which respond to different stimuli to make a complex composition, which is built with more than 2 layers. To summarize our work, we present a framework to design interactive data visualizations without any electronic computation and power.